Hello guys, my name is Amit. So today we are going to discuss this problem, reverse linked list 2. So this is a Facebook interview question. So the question is here. Um, so the problem is if we are given a linked list that is 1, 2, 3, 4, 5 and so on to null, we are given two positions that is M and N. So here in this case M is 2, it means this one starting from 1 and 2 and is 4. Then it means 1, 2, 3 and 4, this one 4 here. So we have to reverse the linked list between these two positions. So finally 4 will come here, 3 will be here and 2 will come here. So something like this. This is 1, 4, 3, 2, 5. So I have submitted it and it ran. It's 100% faster than online C++ solutions. Let me just explain that how the solution is. Okay, so this is solution reverse between I have taken. So I'll just explain that I have initially taken a create linked list function. So create linked list function creates a linked list something as 70, 10, 20, 30, 40, 60 and 70. I'll just explain it. So this is something like this, that I have created a linked list something as 10, 20, 30, 40, 50, 60 and 70, and I have taken the positions as 3 and 6. So 3 points to 30 here, 6 points to 60 here, and output should be something as 10, 20 should be intact, and from position 3 it should reverse the linked list and the 60 should come here and 30 should point to 70. So how what's the logic of it? So initially I have reversed the linked list and found these four pointers. The start pointer points to the sub linked list which we want to reverse. So in this case the position M, start pointer points to position M, end pointer N points to position, that is end points to uh, position N, while the start previous points to one position before start, that is one position before M, and end next points to one position after N, something like this here. Okay, so now in the second step we have to delete this node here, delete this link, sorry. So in this case next of end becomes null, so this is broken. In the third step, we have to reverse this linked list, that is from 30 to 60. After reversing the linked list, the linked list will become something as like this: 60, 50, 40, and 30. Head will be here. So please note that end and start are the local pointers which are pointing to 60 and 30. After reversing the linked list, also end will point to 60 and start will point to 30, right? So in the next step, what we have to do, we have start previous. We'll be just pointing start previous next to end next. That is this here, end start next. Okay, sorry. This is start next is equal to end next, and start previous is equal to start previous next. That is start previous next here is equal to new head, or we can say end. So this is the logic here. Let me just go through that how the things are working here. So um, we'll be starting from this function here. M is 3, N is 6, and we will go ahead with the reverse between, that is A and B. So let me just go to the reverse function. So I've taken four pointers: start previous, end previous, a local pointer C which points to head. So in this case, let me just take it as something as this. Let us go through some iterations to understand the logic. Okay, so C points to here, which is head. So now in this case, we have in step 1 we will be finding the positions of start previous, end, and end next. So I'll be iterating in the while loop until C, that is until C is not equal to null, and I is smaller than n. So n is m is 3 and n is 6. It means when we'll reach here at 60, this loop will exit. So if I is smaller than m, initially I is equal to 1. So if I is smaller than m, yes, this is true. Start previous is equal to c. So here in this case, we have start previous which points to 10. Let me just make make a bit of more space to understand it better. Okay, so now if I is equal to m, no, this is not the case. M is 3, I is 1, it will go out. If I is equal to n, so no, this is also not the case. C is equal to c next, so in the second iteration, c will come here, um, and I will become 2. Okay, now again it will come c is not uh, null, and I, that is I is 2, is still smaller than 6. Now it says that if I is smaller than m, yes, 2 is smaller than 3. Start previous is equal to c, so start previous will come here. I is, this condition fails, this condition fails, c becomes, c points to next, so it goes here, and I becomes 3. Now in this case, this again comes inside because 3 is still smaller than 6 and c is not empty. So here if I is smaller than m, now in this case I is not smaller than m because I and m both are equal. This will not go inside. If I is equal to m, yes, I is equal to m, we will place a start here, right? So now if I equal to n, I is not equal to n, c points to next. Let me just move to c next and I becomes 4 here. It'll go again come on this while loop. C is still not null. I is 4, which is smaller than 6. So this condition will not hit because 4 is not smaller than 3, right? And I, that is I is 4, is not equal to 3 also. This condition will not also hit. Let me just increment C and let me increment 5. So again in this condition nothing will hit. Let us just increment one more time this C and one more time this I. So now in this case I becomes 6, C becomes here. So now in this case I becomes equal to I is equal to m. This is not hit. This condition comes here, that is I becomes equal to n, that is 6 and 6. So in this case end is equal to C. So let me just place a end here, and pointer points to here. Then end next, in this case what happens is end next is equal to C next. So in this case we will have end underscore next will point to C next, right? Now what happens on the next step? Let us just see. So on the next step, C is still not null. I is smaller than, and we increment I becomes 7. So here it will come out because 7 is not smaller than equal to 6. Okay, now in this step, uh, in the next step what we do, end next is equal to null. So here end, this end pointer next is equal to null. We delete this node here. Okay, now we will do a reverse of the linked list. So I have made another video for reversing a linked list. So in this case we will be just passing this linked list to the reverse function. So let me just pass this one, this linked list to the reverse function. So this will be head, and this linked list will have the start, and this linked list will have this end. The reverse function will return something as 60, 50, 40 and 30, and end will be here and nothing will change, right? New head will be here which will be returned, and the start will be here. Just remember that start and end are the local pointers which always point to the same nodes actually. So this is the code for reverse. I'll just post it on the GitHub. Then what happens is we will check that if we have start previous. So in this case start previous was there, yes. This condition is made because if we reversing from the head node itself, but in this case we are having start previous. So what we'll do, start previous next is equal to test. So test is returned from string. So this reverse function, so start previous was 20, so let me just do it as something as 10 20. This is start previous, so this will point to new head, or I'll say just test. Okay, this was start previous. Okay, and next start next, that is this one's next will point to end next. So end next was 70 here, and next, so it will point to 70, right? And next, so let me just run the code on another editor. Let me just do g++. What's the name of this? This is reverse position m to n, g++, reverse position m to n. Okay, it goes and it first created 10 20 30 40 50 60, and then it just prints 10 20 60 50 40 30 and 70. Okay, so 30 comes here, 40 comes here, 50 comes here, 60 comes here, so this is fine. So thanks a lot guys, I'll just post the code on GitHub. Have a good day. Bye.